Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Karen Azmi bin Muhammad. Today I will be presenting about lab activity 1 for lab 3 pneumatic diagram. Pneumatic system. So firstly, we need to develop a pneumatic diagram in Fluid Sim software. So here we have three compressed air supplies for circuit 1, circuit 2 and circuit 3. And we have three two-way valve with push button. So we have A1 and A2 is the same valve, and B1 is for cylinder 1 and B2 is for cylinder 2. The difference between the two valves is just this one, number 1 here, the valve body. Okay, for circuit 3 we're using 5 two-way valve with selection switch. Okay, so first we will simulate the circuit. Okay, as you can see, circuit 1, just as we press the simulate button, cylinder 1 will change its position from left to right here. Okay, this push button is a momentary push button, so when I hold A1, valve A1, the piston will change its position to its original position here. When I let go valve A1, the piston will change its position. Okay, for circuit 2. Okay, so for circuit 2, when I press valve A2, the piston will change its position to the right. So as I press valve A2, we can see the piston moves after I push or press valve A2. When I let go of valve A2, the piston of B2 will retract its position, will go back to its normal position here, as you can see here. Okay, for the next circuit, which is circuit 3, for circuit 3, when I press valve A3 or push button, the airflow from here, it will flow through 1 and go to 4. Then it will push the piston to the right and the piston will change its position. So when I push here, the piston will change its position. When I press it back, it will be at its original position. So I think that is all for the simulation for lab activity 1.
Happy. Open the doors.
For lab activity 2, firstly we need to develop a pneumatic diagram according to the lab sheet. So firstly we have here is the air supply, and this is a 5 two-way valve with a selection switch, and we have 2 manometers, and then we have 2 one-way flow control valve, and output is the double acting cylinder. Okay, so firstly we will simulate, and we need to change the opening level to 10%. Here we can display the opening level, or we can close it. So I'll just put it on, and then we simulate, press play. So here we can see air flows here. Then when I press valve A, the air flows through B1 and goes into D1, and then goes into D2. After it goes to B1, flows to D2, and then the piston will move. I'll play it again. Here the piston moves slowly because the opening level here is 10%. Here. Okay, so first we stop it first. Then next is we change it to 150 first. We change it to 50 first. So next we can observe is the piston changes its position slightly faster than 10%. Here, when we press valve A, piston moves, changes its position. Then we'll try it at 100%. So then play, and when we open valve A, here, when you press valve A, when you open valve A, piston quickly changes its position from left to right. So I think that's all for lab activity 2. Alright, so for the observation, discuss the effect of setting B1 and B2 to 10% to the operation of the pneumatic system versus when they are set to 100%. So in here we can see that when it is 10%, okay, we set it to 10% first, then we simulate, we can see that here nothing happens on the right side. We press valve A, we can see that piston C, or cylinder C, changes its position from left to right slowly. Okay, this is when it's 10%. Here. Okay, then we stop the simulation. and we compare it to when we set it to 100%. Then we simulate. Okay, after I press valve A, piston C moves immediately. This is because the opening here is 100%, so it moves. As I press valve A, piston C moves to the right, changes its position.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmin Ahmad Kamil. Okay, now I will continue for the last lab activity, which is lab activity 3. Okay, here is our pneumatic system that we have done based on the instruction of the lab sheet. Okay, we use 4 directional valve, which is 3 of them are 3/n wave valve and another one is 5/n wave valve. Double acting cylinder, 2 pressure valve and also air compressor. So how it works? Okay, let's run the system. Okay, here we can see that the air compressor will supply air pressure into the 4 different parts, okay, which is to the A1 valve, A2 valve, C valve and also A3 valve. Okay, we can see that the initial condition of the system is the deflation of the cylinder due to the direct air pressure that goes from the air compressor to the C valve. Okay, and lastly go to the deflation point of the cylinder. Okay, now we want to see the reaction if the valve is pressed. Okay, when we press the A1 valve, nothing will happen. Same goes to the A2 valve. But if we press the both valve, okay, we can see that the 2 pressure valve will let the air flow through it and goes to the C valve, which is somehow will alternate the another part of the valve and goes to the extension point of the cylinder, and the cylinder will expand. Okay, so how this actuator actually works? Okay, so this is actually the logic function that we need to comply, okay, before it goes to the actuator. So this 2 pressure valve actually act as an AND logic gate, okay, where we need to have signal from both valve. Okay, we can see that if we push one of them, okay, nothing will happen. But if we push simultaneously, okay, the pressure valve, the 2 pressure valve will let the air flow to it and will go to the actuator. Okay, so that's how it really works. Okay, based on the question why the C valve doesn't need any spring, okay, let's run the skirt system. Okay, you see that if we push A1 and A2 valve, okay, we can see that the C valve will alternate of the other side of the direction. Okay, and when this actually the momentary push button where it momentarily push, okay, and then it will release back. Okay, so what will happen here, you can see that it hold the current state, okay, where it where it's still on the other side of the valve. Okay. Okay, why we don't need spring? Because we have the other valve, okay, which is denoted as A3, where we push, okay, we push it and somehow will go back to the initial state of the system.